Hi, everybody. I'm Vince Mickens, and welcome to the latest edition of All Things Aviation and Aerospace. As all of my loyal viewers, listeners, and followers know, I like to include every option and possibility when it comes to aviation and aerospace careers. And as a result, I've covered a wide variety of career options, including, most recently, the availability of numerous aviation scholarships, robust aviation and aerospace internship programs, and aviation and aerospace summer camps. But since I hadn't done anything in a while with NASA, I thought that it would be a great time to reach out to them and seek out something different that most of us might not be familiar with. Well, they obliged me. So thanks to the director of NASA's Johnson Space Center, Vanessa Weich, I was introduced to a significant aspect of NASA space exploration, space architecture. Yes, initially I thought, space what? But as soon as I started to learn what space architecture actually is, a fairly recent label in space exploration terms, I might add, and that it has been around since our beginnings in space exploration, it made a lot of sense. So I did a deep dive, did some research, and was really blown away, although not necessarily surprised about all that is involved with space flight and space exploration architecture. My biggest takeaways are human-centered design factors with space habitability, the most important aspect of designing with humans in mind. Things like life support, protection from the elements of space, and comfort. I mean, after all, we're talking about somewhat confining living and working quarters for extended periods of time. So I have three great guests, two of whom are very experienced in space architecture, and one who I affectionately refer to as a newbie, but is an inspiring representation of our future in space exploration. This was originally going to be one show. However, because of all three having very compelling stories to tell and even more captivating insight on this unique aspect of NASA, I decided to break it up into three separate episodes. Episode part one features Dr. Robert Howard, the Habitability Domain Lead at NASA Habitability Factors Branch, as well as the co-lead of the Center for Design and Space Architecture at the NASA Johnson Space Center. Dr. Howard holds bachelor degrees from Morehouse College and Georgia Tech. He has a Master of Science degree from North Carolina A&T State University, and he got his doctorate from the University of Tennessee Space Institute. For part two, also from NASA, and she's my newbie, is Clare Luckey. Clare, who recently started at NASA in Mission Analysis and Integrated Assessments, or MAIA, as NASA affectionately calls it. She is also part of NASA's Mars Architectural Team, or MAT. Then stepping outside of NASA, part three will be my interview with Dr. Olga Banova, the director of the world's only Master of Science Space Architecture program, part of the Sasakawa International Center for Space Architecture at the University of Houston. Yes, you heard me correctly. It is the only space architecture graduate program on planet Earth. Dr. Banova is also a research professor at the University of Houston's Cullen College of Engineering. So let's get things started. Here is my interview with Dr. Robert Howard. Dr. Howard, welcome to the show.
Hello, Vince. Thank you. It's good to be here.
It's great to have you and looking forward very much to this conversation. I have learned a lot pre-show about it, but now we get to hear it directly from you, and our audience gets to learn about something that is, I call it unique. It's been around for a while. You've obviously been doing it for a while, and from the research I see, it's been a thing going back decades, but it is still something that we don't hear about. We hear about the obvious. We hear about the astronauts and their travels in space to the space station and the plans to go to the moon and the plans to go to Mars and things like that. But there's a lot more to it than just, putting on a spacesuit and going up there. So you have quite the background in this. So I think it would really help our audience if you could tell us a little bit more about your background and your education and how you got to where you are now.
Sure thing. So it starts when I was in diapers, basically. My mom told me when I was 3, if Mr. Rogers' Neighborhood or the electric company was on, if I was in the room and not doing anything, I might look at the show. But I knew what time, this is at the age of 3, I knew what time and what channel to turn Star Trek on. So I love space ever since I was little. I would go to the library and I would automatically find the space section and just read all the books I could about space exploration.
You were a baby
Right.
Trekkie.
Absolutely. Not really sure why a 3-year-old liked Trek, but I did. So anything space I could get my hands on, that, Space 1999, whatever.
Wow.
When I got to high school, it got to the point where people would come and talk to me about space because they knew that I knew more about it than anyone else at the school. And so I knew that was what I wanted to go to college for. I'd started out thinking I was going to go into the Air Force and use that to get to NASA. And I'd gotten as far as getting accepted to the Air Force Academy. But my parents discovered NASA had just started a scholarship program at Morehouse College. They sent down to Morehouse a packet of all the things I'd done in high school. Morehouse gave me a call and said, "Will you fill out this application so that you can take this scholarship?" It was full tuition plus internships at Johnson Space Center. So that trumped the Air Force Academy.
So
Canceled my.
I got to interject here. How long ago was that? Because that's really incredible that your
Mhm.
parents sought that opportunity out for you, and then you pursued it and got it.
My parents were incredible. They were both university professors. My mom taught everything from elementary to undergrad, so they were focused on making sure we succeeded. This was in 1989. I graduated high school class of 89.
Okay.
And real at the point of graduation, I still thought I was going to the Air Force Academy. So it was in those intervening weeks right after graduation that my parents found out about the NASA scholarship. That program's not still around, but there are other scholarship programs. I'm sure you're informing your viewers about that they
Yeah,
can apply to.
absolutely. As a matter of fact, I'm going to be doing a show on specifically on NASA scholarships. There are a lot of other programs around, but the fact that there was one 34 years ago and you were able to take advantage of that, it makes more of a statement not only that it happened that long ago, but it kind of reinforces the fact that these programs of some sort are available and just need to be sought out, and the kids need to know about them and the parents need to know about them. Your parents being educators, they were already kind of in the loop, so to say, to know to look for it. But
Exactly.
that's just really great. But go ahead.
Sure thing. And throughout my education, I got 4 different degrees. NASA paid for all of them, so it was an amazing journey to get that much education for free.
Wow.
When I got to Morehouse, I didn't know that I wanted to be an engineer. I wasn't exposed to engineering growing up, but I had a home computer, so I taught myself computer programming. I started out in computer science because that was familiar to me and it was comfortable. It was at NASA though, I was finding that I wanted to do more than what I was being challenged to do in my internships. They weren't space related enough for me.
Okay.
And I had the opportunity to interact with some astronauts, Frederick Gregory in particular. I had actually written him when I was in high school, and because he attended the academy, and he wrote me back and gave me some advice. I went and met him again, and as we talked, he actually took me around the astronaut office and spoke to other astronauts. At the time, computer science was not as big as it is now, so they didn't think it was as important as it is, but they said, "You really want to major in hard engineering." And he actually took me water skiing too. He said, "We can take off work." It was for another astronaut's birthday. He called it official business called surface kinetic investigations. So that was kind of a hilarious opportunity.
Okay, that's really creative.
Mm-hmm. But based on his advice, I came back and changed my major. It was the beginning of my junior year. I switched to general science at Morehouse and aerospace engineering through the dual degree program that Morehouse had with Georgia Tech. So I got my second bachelor's in aerospace engineering. I liked that, but one of the things that I felt was missing, I learned a lot about vehicle systems in my degree, but not much about how the human interacts with the vehicle. So
Okay.
when I went to my master's, I went to North Carolina A&T State University for my master's. Got that in industrial engineering with a focus in human factors. That sort of gave me the other piece of the puzzle, how to address the human system.
So
From
you were constantly exploring, okay, how can I take this to another level? How can I take this
right.
further? And that type of
Hmm.
thing. And I'm going to go back on something that I think is really important, and I like my viewers to hear that you said, and that is that you reached out to an astronaut. You just reached out to him, and that ended up coming back in a very positive way for you, which then gave
Exactly.
you guidance with being introduced to other astronauts and being exposed to other aspects of space exploration of NASA, and giving you the ideas to continue to move forward with your education and that type of thing. All of it comes together. And
Right.
I hats off to you on that, by the way, because I think that's a great example for people to hear about.
It's really important to reach, if you know what you want to do, you've got to reach out to people in that field because they know things about how to get there that you won't find from anywhere else. Because no matter how good your guidance counselor is, unless they worked in that industry, they don't know all the ins and outs, where someone who works there would know and be able to help you better.
Absolutely. Amen to that. And the other part of it is, Robert, is that, and the reason I'm emphasizing it is a lot of young people have a tendency to be shy about it and think
Mm.
that they're going to, the astronaut or the pilot or whatever is going to bite them. And I'm like, no, most people in this industry, both aviation and the aerospace side of the industry, absolutely love sharing
Exactly.
everything that they know with whoever is interested in it. As a matter of fact,
Mhm.
once you get them started, you usually can't shut them up.
That can be true.
Yeah, yeah. So you furthered your education with the dual degree. Then you
Mhm.
went to North Carolina State, um,
A&T State,
A&T State. Uh, that's a very important part of that.
very important distinction.
Yeah, very important to say. And then what happened after that?
After that, I went to get my PhD. I went to the University of Tennessee Space Institute. It's a teeny tiny school in Tullahoma, Tennessee, which is the middle of nowhere.
Okay,
But what they had was something really special. One of the professors I worked with, Dr. Gary Flandreau, he had been at the Jet Propulsion Lab before his time at UTSI. He was one of the engineers who developed the trajectory that Galileo used to go to the outer planets. So studying under him was really a phenomenal treat, and that was kind of the main draw of that university. I wanted an aerospace degree, but I wanted it to focus specifically on space systems, and Dr. Flandreau was the key for me doing that.
yeah. How does space systems for you transition into space architecture? How did that come about? Because it doesn't sound like space architecture was on your radar at
So
up to that point.
space architecture is somewhat of a new term, even though we've been doing space architecture since the beginning of the space program.
Okay. Yeah.
If you go to space architecture, I think it's spacearchitecture.org, but there's a website of space architects. It defines space architecture as the theory and practice of designing and building inhabited environments in outer space. So that's really everything about building a system that allows people to live away from planet Earth. It involves architecture, it involves engineering, it involves science, it involves space architecture, it involves industrial design. Pretty much every technical field of knowledge comes together in space architecture. So you might have a space architecture degree, or you might have any of those other degrees, but it's how you're taking that knowledge and synthesizing it to get us off of planet Earth.
Sure. It totally makes sense, and it makes sense. It goes back that far since the space program began. Can you give us an idea of what you and your team do in
Mhm.
various areas and within your department
Yeah.
and what your responsibilities are?
So with my focus being habitability, we look at the aspect of how does the astronaut live or work in that space environment. We're not focused on, say, the life support systems or the thermal systems. We're more focused on what's the volume, how is the volume arranged, what sorts of functions need to be present within that volume, and how do you decide which ones need to be close to each other, which ones can actually share the same space, which ones need to be kept apart from each other. And when we're developing these new concepts, we've never lived on Mars. The longest we've been on the moon is 3.5 days. We've only had a few spaceships that have operated in microgravity, so it's still new. So for almost any mission, we're creating a new system. We have to understand how does that work. So after the initial ideation, where we come up with the idea of we want humans to be able to live in this environment, we start developing concepts of what that looks like. That's a mixture of CAD, some sketchwork, some calculation. So depending on your focus, you might be sitting at a computer, you might have a pen and paper in hand, you might be using a CAD model, you might be using Excel. Any number of different aspects come together to define what might that spacecraft look like. Once we have ideas, we start to prototype. That can be both virtual using VR, or it can be physical.
Where
Initially,
you
you
actually
start out
make a
low.
model?
Well, we can make scale models, but sometimes we make full scale mock-ups that we can actually go inside and interact with.
Okay.
We'll start
So,
out low fidelity. Oh, go ahead.
no, I was just going to ask you, sorry to interrupt you. I was going to ask
Mhm.
you, though, um, a lot of this is collaboration with the astronauts that have already been up and experienced traveling in various types of space capsules, et cetera.
It is, although the early stages, we do some development before we bring the astronauts in, since their time's
Okay.
really limited. So we don't engage them until we have a more fleshed out version of what we're looking at.
Okay. Okay. So you were saying you build a mock-up and go ahead.
We start out simple. So whether it's in for VR or for physical, we just kind of roughly define the shapes, make sure we've got things defined the way we want them. Then we'll increase the realism, the fidelity, so to speak. Then we do what's called human in the loop testing. That's where we bring people inside that environment and have them interact with it. It might just be a component test, like if it's a chair for the moon, we might just have them sit down in it. Or if it's an entire spacecraft, we may simulate a mission and have them go through the simulation. For instance, we would go to Arizona in the desert with a pressurized rover, and we would simulate a 3 day, a 7 day, or a 14-day mission where they're using that vehicle to go explore as if they were actually on the moon. So we take that evaluation, whether it's a simple one or a complex one. We ask them all sorts of questions about how the mock-up performed, get their feedback on what was good, what was not good, and we refine the design from there. That gets us eventually to the point where we can write what's called requirements. Those are basically a list of do's and don'ts. So it's everything that has to be true about the spacecraft. For instance, the spacecraft shall have a floor to ceiling height of 2.5 meters. That's an example of a requirement.
Okay.
Those requirements are then put together, and that lets NASA decide what they want the vehicle to be. Then that's when they can tell someone how to build it. Usually what we'll do is we'll either hire a contractor or we'll partner with a international space agency, and they go off and build the actual spacecraft for us.
Got you. So a couple of things then. Well, let's talk about this first of all. So a big factor, and you touched on it a little bit, is the human factor. Can you
Mhm.
expand on that, and can you also talk about um, what somebody's background might be or needs to be, education wise, et cetera, to deal with that aspect of what you guys do?
Sure. So, easy way for you to think about human factors. Let's go back to COVID when we were at the beginning of the lockdown and everyone was staying at home. And let's make it a little bit worse. Let's take you, for instance, Vince, and let's take what we can see of you on the screen. So this part of your office. Let's imagine that one other person joins you in there, and you two can't leave that area for the next month.
Oh God.
So
Okay.
we have to think about what is everything you need to live, be productive, be healthy, be happy in that environment.
Gotcha.
And how do we arrange it? How do we fit a toilet in that volume? How do we fit beds in that volume? How do we fit medical care in that volume? Oh, and not only are we locking you in, we're deleting the rest of the universe. So you can't call 911, you can't call a plumber, you can't call anybody. Or you can call them, but they're on another planet, so they can't help you.
Right.
They can give advice, but you're going to have to do everything. So
Wow.
where are the
Yeah, and so that brings me back to the question of what background do people have that
Mhm.
deal with that aspect
Yeah.
of that?
And that's why it's a team, because no one background can do all of this.
There you go.
Industrial designers are really good for developing what does the shape of that product look like. You have engineers who develop all of the technical specifications. You've got psychologists who look at the psychological, the mental concerns going on. You've even got medical doctors that weigh in. All of that comes together in defining what this space needs to look like. There are even acoustics people, there are toxicology people, there are material science people. So it's a huge universe of people. Of course, architects.
Yes.
It's a huge universe of people that come together.
Yeah. So I had a very interesting discussion with Dr. Pablo de Leon, a professor at UND Space Studies, and of course he deals with the spacesuit and spacesuit design and things like that. But he brought up two things that stuck with me. One was one you just touched on, and that was if you're going to Mars, that's a 6-month trip, and there could be things that you need en route, such as if you have a dental issue or things like that. And he mentioned that. But the one that really stood out to me that I thought was, well, yeah, that sounds pretty complicated, was protecting the astronauts from the radiation, from of being in space and actually moving closer to the sun as you head to Mars. If I'm stating that correctly.
Sort of.
Kind of.
So yeah, let me see how to say this. When people say it's a 6 months trip to Mars, that's an approximation. That's kind of like saying, how long is it to get from New York to LA?
Right.
We haven't said if you're driving or if you're flying or if you're taking a train or even if you're taking a boat. Depending on how you get there, the length of that trip changes.
Okay.
6 months is typical of a chemical propulsion architecture using what's called a conjunction class trajectory.
Okay.
That's what most of the discussion about Mars has been focused on. But there are other systems. So you might have heard in the news talk of something a trip to Mars in as short as 45 days or 3 months. That's an experimental technology that's not available yet, but engineers are working on.
I
You may
had not
also
heard
hear
about that. What kind of propulsion is that?
BASIMR. It stands for variables. I may get this wrong. Variable specific impulse magnetohydrodynamic propulsion. I think that's the right name.
Okay, close enough.
It's basically a system that uses electromagnetic forces to accelerate plasma.
Okay, that makes a little more sense, at least to me. I'm not sure about our viewers and listeners, but
Very
yeah,
futuristic, very advanced.
yeah.
It's actually a former astronaut who championed the concept, Franklin Chang Diaz.
Wow.
There are other people looking at different forms of nuclear propulsion. Some of those are fast, some are slow. So you may also hear people talking about a 1 year trip to Mars.
Right.
That's
Hmm.
that's a low thrust, high efficiency propulsion that doesn't use as much propellant but takes longer to get there.
Does it make a significant difference as to whether that, since we're on the Mars topic, of going to Mars from the moon versus going to Mars from Earth?
Um, that's kind of like saying if you're going to from DC to LA, are you going to the moon from the Air and Space Museum or are you going to the moon from Dulles Airport?
Hmm.
Now, if you know DC, those two are really close to each other.
Right.
So the moon is basically next to Earth. So the distance is about the same.
I was thinking
When
about the
people talk about
gravity.
the gravity is lower on the moon, so if it's something that's leaving the moon versus leaving the surface of the Earth, it takes less energy if it leaves from the moon.
Okay.
But those questions assume a lunar architecture because how did whatever got on the moon get to the moon?
Right.
There are architectures where it makes sense to build up equipment at the moon or in lunar orbit and leave from there to go to Mars. There are the other architectures where you build everything up in Earth orbit and go to Mars. There are arguably the potential for architectures where you go directly from the Earth's surface to Mars, although that requires rockets we haven't built yet. Not even Starship can do that.
Okay. So let me ask you this while we're in the subject of this, Mars and Moon. What are you guys currently working on? Because we're talking about going to the moon in a few years,
Right.
and we're
Mm-hmm.
talking about going to Mars in, I don't know, 5 or 10 years, whatever it is. So it's right around the corner, especially in the terms of what you guys do. So what type of things are you working on, for example, with regard to the moon?
So I've had, over the course of my career, I've had the opportunity to work on all sorts of different lunar vehicles. Most of my time right now is spent on the Lunar Terrain Vehicle. That's an
Okay,
unpressurized rover. You could think of it as the successor to the Apollo Dune buggy. I also do some work on the pressurized rover, so think of more like an SUV with something that's got a cabin so you can take off your spacesuit.
got you.
So
So,
those,
hmm,
oh, good.
go ahead.
Those two give us mobility. When NASA went to the moon in the 60s, The first 3 missions, they didn't have any mobility, so it's just the crew in their spacesuits. They could walk around, but they couldn't go very far because you're limited to as far as you can walk. When they had the lunar roving vehicle, which was their unpressurized rover, they could drive further. What we want to do with the LTV is make it a much more capable vehicle. So it's sort of the next generation LRV. We can drive, we can do a lot more with it. We can reuse it, use it over multiple missions. We can carry things with it. So it's not just the people, but they can carry lots of equipment. We can even transfer equipment from landers to whatever our surface habitat is with
Would it
with the
stay on the moon, or would you always, would you, how does that work?
so in our current plan it stays on the moon.
Okay.
But people could create plans where it doesn't. So that's where it gets into there is the current architecture, but there are an infinite number of possible architectures. It's kind of like you're asking, what does a car do? And it depends on what car you build.
Yeah, man, you put this stuff in plain English. It's just got me going. Okay, yeah, okay, that makes sense. Yeah, right. But it does. And so you're working on those 2 vehicles now. The pressurized vehicle. What did you call it again?
Pressurized rover. It's
Okay.
basically kind of like an SUV. It's got room for 2 astronauts to drive around in it, and it's got a place where they can put on spacesuits to go outside, come back in, place to sleep, place to eat, place to use the
Oh,
bathroom.
it's that big.
It's still kind of tiny,
Okay.
but
Well, when you start
goal is,
talking about taking on and off spacesuits and
Mhm.
things like that.
Let's just say there's still some design challenges.
Okay.
We're working with an international partner for the pressurized rover, so they're going to have to solve some pretty intricate questions. We've looked at them and developed some approaches, but they're going to have to figure out for themselves which way they want to run.
Do you have to coordinate with, or do you coordinate with the guys that design the spacesuits, and deal with that side of it in terms of making that all work with these rovers that you're in and vehicles that you're working on?
Yeah. Now it's a large distributed team, so any given person on that team may never see my face, hear my name, know anything about me. But we do interact with the suit team. We actually just did a test yesterday. We have a test facility at Johnson Space Center called the Argos. It's a reduced gravity facility.
Mm-hmm.
They basically have a track that runs on top of it with a motor connected to a cable that runs down to a harness. You can put a test subject in a spacesuit, put that spacesuit on the harness. The harness pulls up with the force to reduce the effective gravity on them. So if we want to simulate the lunar gravity, it'll pull up to counter all but 1/6 of their weight. So they're moving around as if they were on the moon. It's not a perfect simulation, it kind of gives you the approach. We were looking at a low fidelity mock-up of our NASA reference version of the lunar terrain vehicle. It's not the version that we're going to send to the moon. We're going to have a company design and build one version. We have an internal version that we use to understand how do people need to interact with a unpressurized vehicle. We
Yeah.
were doing a test to see how do they interact with this, with how can they sit. We looked at 2 different concepts. How can they change a tire? How can they get to tools? Just sort of looking at gross movements around the vehicle.
Yeah.
And we
So
had the suit team with us.
sure. So Robert, as I mentioned, we have a variety of people that watch and listen to the show, but we have a lot of young people that are probably, looking at it and saying, okay, so how do I get into this? So this, a high schooler, maybe middle
Mhm.
schooler, but most likely a high schooler that has an interest in space, the space exploration, doesn't have a clue where to start, not sure if they really want to be an astronaut, but know they want to do something, know they may want to work at NASA or the Jet Propulsion
Yeah.
Laboratory or whatever. What are your recommendations based on your experiences to them about what to think about, what to get involved in, how to get started, what direction to go in terms of their education, et cetera? I know I just threw a lot at you, but
Start immediately. Doesn't matter what age you are, whether you're an undergrad student, a grad student, high school, middle, elementary, not even in school yet. There's no age that's too early or too late. Start reading everything you can. The internet is a huge advantage that I didn't have when I was little. So you can Google to your heart's content about space. And with things like LinkedIn and Facebook, you can actually find people who work in the space industry and speak to them. You definitely need to focus on your schooling. GPA is the number one driver that's going to determine whether you can get here or not.
Okay.
Math and science courses in particular. Also, SAT prep. If you're not already in college, you need to take an SAT preparation course. You can do ACT too, but SAT is more popular. My parents learned with each of us how to prepare us for college better, so they started me with SAT preparation courses. My younger brother got it by accident because they didn't have a babysitter, so he had to start coming anyway. So he started taking SAT prep in sixth grade. By the time he got to 12th grade and took the SAT for the last time, he only missed one question on the entire test.
Wow.
So it is that early preparation that is key. That makes so much of a difference.
Yeah.
You need scholarships and you need internships.
Mm-hmm.
The worst thing to do is to be a senior looking for a job. In the in the science and engineering fields, you don't want to be in that shape. You want to find your job through an internship starting starting somewhere in your freshman or sophomore year.
Wow. Yeah. So I was just that you hit on two key points. The internships. I've seen so many students that once they've gotten into an intern program for whatever it is that they're trying to do, they usually end up with a job right after they graduate. Actually, they're usually offered one before they graduate.
Mm-hmm.
So yeah, that's absolutely key. And then we were talking earlier before we started the show about the importance of scholarships and the availability, more important, of
Mm-hmm.
scholarships, and that a lot of kids unfortunately don't always take advantage of, and they're out there. Every
Right.
kind of scholarship you can think of. Some are small, some are big. You know, some cover everything, and some will help you along the way. So I think that's really key. I wanted to ask you, going back to, what is it about what is now called space architecture that really drew you into doing all of what you do now, that's got the label space architecture?
To me, it's the aspect of creation. Before I even knew there was a field called space architecture, before I even knew there was a field called engineering, I would design and come up with space concepts. My mom tells me, I vaguely remember this. I discovered that if you took a key and scratched it against a wall, it would leave a mark like a pencil, but it couldn't be erased. Now, you would think I would get in trouble for doing that. I was about 8 years old, but she came into my closet and discovered I had drawn out an entire spacecraft control panel. And she was just so amazed that I got away with it.
Of course you
But,
did, because she saw you were doing something creative and educational. So, and her
but
being an
just,
educator, she's like, okay, well, at least you're doing something productive.
yeah,
Yeah.
but just the idea of being able to create things that are new. I look at the moon and I think, what would it be like if someone can look up into the sky and see Earth? And they're at home when they do that.
Yeah. You know, you brought up earlier that there are a lot of people that go into these projects. So the team for building the rover, for building the pressurized vehicle, and all the other architecture that you guys are looking at for space has a lot of people involved. So one question I have for you: how big is a team like your team for the rover, um, and that type of thing?
So it's all teams. It's literally even teams of teams. I couldn't exactly tell you how big the rover is because there are different teams that make up the rover team, and you don't necessarily ever see everybody all in the same room.
Right. So I was going to
I,
say some of them are from different parts of the U.S., from companies, et cetera, and so forth. Right.
exactly. Right. Mhm.
Yeah. Yeah.
So the team that I lead, the Center for Design and Space Architecture, we're a small team of about 10 people,
Okay.
and we've got maybe about half the team working the lunar terrain vehicle, the other half working the pressurized rover and other mobility studies.
Yeah.
We interact with other engineering teams. Sometimes some of those teams are focused on design and some of those teams are focused on testing. But that broader team interacts with other teams that deal with things like what's called acquisition, which is basically how do we take an idea and put it out to a contract for a company to bid on.
Sure. How do young people, if they're interested, like they're in high school, Is there an opportunity for them to come and tour? Like if they live in the Houston area or they're visiting Houston because of family or friends or whatever, to come and tour what you guys do or some aspect related to it there at Johnson Space Center?
So that does happen, and it happens in different ways. Every NASA center has some kind of visitor center. The one for Johnson Space Center is called Space Center Houston. They have tram tours where you can actually get on a tram and they'll drive you around. You get to go inside mission control. You can go into our mock-up facility and you can see several of our mock-ups, including that Argos rig that I was telling you about. If they'd been there at the right time, they could have seen our test yesterday, but there will be more.
Yeah, I would think
That's
that's very important to come and see for important and inspiring
exactly.
to come and see in person what you guys do and what's all entailed with it because NASA is quite the operation in terms of all of the things that NASA's doing at the various space centers and research centers, et cetera, and that type of thing. So
I
I
forgot
think,
to
go ahead.
I forgot to mention other thing. It's not a tour, but I strongly recommend anyone who knows they're interested in space to go to space camp. I used to always want to go. My parents always said they couldn't afford it, but my senior year in high school, I found out about a space camp scholarship. And I bet that scholarship is still around. You
Yeah.
basically write an essay, and if you win, they'll pay for your trip. So you get to go to space camp. I had a fun story with mine because it was the essay contest. It was a question. You're the director of NASA with limited funds. Sound familiar? They
Right.
said, will you choose a space station, a moon base, or a Mars mission, and why? And when they said creativity is part of the answer, I knew I couldn't choose any of those three options. To me, it wouldn't be creative enough, no matter what I did with it.
Hmm.
So I came up with another option. It was a spacecraft that I called the Mobile Space Base. It was a modular vehicle that could orbit the Earth like a space station. You could reconfigure it into an interplanetary spaceship, refuel it in orbit, fly it to either the moon or Mars, separate it into descent elements that each had their own landers, landed on that surface, and you now have a moon base or a Mars base. So my answer was do all three.
And boom, you got in space camp.
I got in space camp.
Thanks for talking about that. Not only sharing the story, but the importance of about the essay. Most scholarship programs or scholarships that are available require an essay as part of the application process, and that seems to intimidate a lot of people that are nervous about it. But you brought up an important point. Just be you and say what means the most to you in
Exactly.
terms of your passion for your interest in space exploration, and it'll take care of itself in most instances.
It really will. And don't be afraid of writing. When you have a writing assignment, break it down into pieces. If you can keep breaking it down until each piece is only a sentence long. And then it becomes easy to write because it's easy to write a sentence. It's hard to write a 3-page paper. But if you
Yeah. So as we wrap things up, that brings us kind of a nice transition to this, and that is specifically getting a degree in space architecture is not a norm. I found out very quickly that there are only a few schools in the world that actually have that as a major and as a graduate program. What are your thoughts about that, and what are your recommendations for somebody that is going to want to try to figure out what aspect of space architecture they're actually interested in, especially when you do space architecture, uh, habitability, and human factors?
Mhm. Follow your passion. That's the most important thing. You know you want to end up in space, but there are literally hundreds of different degrees you can use to get there. Find what excites you the most, and that's what you need to zero in on because you're going to be the best at the things that you're most excited about. If it's a area you don't like, then that project or assignment you have in school, it's going to be boring, it's going to be hard. You're not going to want to do it, and you're not going to do your best. Versus if it's something you're excited about, you won't mind doing the homework. Even the parts that are tedious, you won't mind as much, but you'll even find yourself wanting to do more than the assignment asked for. That's when you know you're in the right field.
Dr. Robert Howard, this has been very enlightening, and I love the way you give the what am I trying to say? The way you do the comparison or the analogy that makes a whole lot of sense on everyday things that we deal with, and then applying that to a very specialized field. So I really appreciate you taking the time to be here and to talk about this. And I hope that it has inspired some of our audience to really take a look and give it some consideration and go after it.
My pleasure, Vince, and good luck to everybody.
Yeah, thank you very much. Hey, that does it for part one. And in part two, I will talk with Clare Luckey, the young lady I was telling you about that I call the newbie. And she's at the Johnson Space Center's Mission Analysis and Integrated Assessments and is part of the Mars architecture team. I highly recommend that anyone in middle, high school, college, and even postgraduate watch and listen to this interview. Clare is representative of many who figured out things along the way. It was a great conversation. Thanks again for joining us and hopefully enjoying these enlightening discussions with very smart and very talented aerospace professionals. As you know, my goal with every show is to inspire any and everyone who has any kind of interest in literally any aspect of aviation and aerospace. And I encourage you to consider every option and every possibility. Thanks for watching this edition of All Things Aviation and Aerospace, a media presentation of Private Air Media. Hi, I'm Vince Mickens. Welcome back to part two of my three-part series on space architecture and becoming a space architect. As I mentioned in part one, the three interviews that I did with the two aerospace professionals from NASA's Johnson Space Center and the director of the Master of Science in Space Architecture program, Sasakawa International Center for Space Architecture at the University of Houston's Cullen College of Engineering, boy, that's a mouthful, were, to say the least, riveting and incredibly insightful about this very unique field in space exploration. So you heard from Dr. Robert Howard, the habitability domain lead at the NASA Habitability Factors branch and co-lead of the Center for Design and Space Architecture at NASA Johnson Space Center. Now it's time to check out this conversation with a representative of the new generation of aspiring young aerospace professionals, Miss Clare Luckey. You have a kind of an interesting path, at least an interesting major in school for your undergrad. If I have it correct, you were space weather engineering. So
yeah,
let's start with, tell us what that is, and then tell us how that happened.
Yeah, so obviously that's a very specific degree program. The program itself is very small. But when I got to the University of Michigan, I actually wanted to do chemical engineering. That's what I had my mindset on when I got there. And I knew that I wanted to do a minor in astrophysics and astronomy. So after my freshman year, right before I actually declared my major officially, my advisor was like, hey, I don't think that chemical engineering and astrophysics together are really going to get you where you want to go. Have you heard of at the time, it was the Atmospheric, Oceanic, and Space Sciences program, and space weather was within that. And so I said, yeah, that sounds pretty cool. I've never heard of it, but it sounds pretty cool. And so thanks to her, I guess that's how I got started in space weather. And so just to kind of explain, I guess, more so what space weather is.
What space weather is, you took the words right out of my mouth.
Yeah. So space weather has to do with understanding the space environment. So like solar physics, solar storms, all that, the radiation coming from the sun, and then things like galactic cosmic rays and just the cosmic microwave background. So understanding the space environment, it's not weather per se, although there are some meteorologists in that program or in that department as well. But space weather focuses on the space environment and what we call weather coming from the sun.
Yeah, and which makes total sense. I even remember some of that from science days. But let me go back for a minute, because chemical engineering, but with a hint of interest in space. So take me back when you were younger, before college, and where did this all come from?
I don't know if I can pinpoint it exactly where it came from. I was good at chemistry. I enjoyed it. I do. So I'm thinking way back to middle school, actually. I remember being in this after school program called like Future Cities, I think is what it was called. And a bunch of my friends, we just decided to join the Future Cities Club. And one of the challenge for that year, so the concept of the program is like a bunch of middle schoolers compete to solve some problem that they've decided for that year. And it's like designing a city. So almost like not quite Sim City, but designing a city. And that particular year, the challenge was to design a city on Mars. And we didn't do super well, but I I remember really enjoying that program. And so it's
You
really
found it fascinating.
Yeah. And so fast forward to now when I work on the Mars architecture team, kind of doing not that, but very close to
Very
that.
updated
It's always
Sim
cool
City.
to get. Yeah, it's always cool to think back on that. But yeah, like I said, I was good at chemistry, and when I freshman year, I mean, I didn't really know what was going on. I just got there. But I knew that I had an interest in space. I had an interest in planetary sciences. And I wanted to, back then, do something with like the formation of planets and chemistry. And so that's how I rationalized it in my mind, making those two work. Yeah.
So, anybody in the family, your mom or dad or anybody have a similar background or any type of engineering or background that's related to what you do? I'm just digging back to see where it might come from. Where'd you grow up?
Neither of my parents are engineers. My grandfather actually used to work on aircraft way back in, I would be remiss if I tried to pick the year. I don't know.
Was he like a maintenance technician or something?
Yeah, he was a maintenance technician on aircraft.
Okay. Military or civilian?
He was in the military, but I don't know if he worked on the aircraft. I don't know if he worked on military aircraft.
Okay. Gotcha. Yeah. So some of the technical might have come all the way from back then.
Yeah, maybe it's just in my DNA. I don't know.
Yeah. So you did this undergrad and everything, and you really liked it. And where did that translate to? Because you mentioned it, but where did it actually translate to you saying, you know, I want to do this graduate? How did you even find out about the graduate program for space architecture?
Yeah. So, another aside, when I was younger, I wanted to be an architect. I've always kind of enjoyed design, and you know, when you're young, you're trying a lot of things out. You know, you're just, I want to try this, sure,
which is great.
So,
I mean, talking out, figuring it out. And was this also middle school or even earlier? Your interest in architecture?
High school. In high school, I took like a art history class that I really loved. And I've always been like good at drawing and designing. And so I got into another school for architecture. And so it was between the University of Michigan's engineering program and Carnegie Mellon's architecture program. And I got a scholarship to the University of Michigan. So I was like, well, yeah, I'm going to go where the money is.
And your mom and dad were like, yeah, you're going to University
they're like,
of Michigan.
yeah, you're going to stay here.
No, but that's, what an interesting path. You know, it's kind of important. I like talking about this on this show because a lot of the viewers, both at the student level and parents and even teachers and everything, it's good for them to hear the different paths that someone like yourself has taken. You're not alone. There are so many students that are trying to figure things out, have ideas of what they think they like. What it does sound like to me is that you kind of went with your interest and passion, even though you weren't sure where it was going to take you, and then figured it out along the way. So you,
yeah, you know, I always get this question. Like, we've had interns at work, and they're always kind of like, oh, you know, how did you get to where you're going? What should I do from here? And I try and tell them not to overthink it, because there's no way for you to plan every single step. You know, you set the intention. I said, hey, I want to work at NASA. I had no idea how I was going to get to NASA. but it had been a goal of mine for a long time. And so you kind of just have
high school
to,
or college?
Since high school, I did lots of summer programs. So I did a bunch of engineering programs from, I think, 7th grade through the end of high school at the University of Michigan, their summer program for engineering. And then my senior year, or the summer going into my senior year, I did a summer program at the Massachusetts Institute of Technology.
MIT.
Actually, in that program, I did an architecture project. But all the pieces in hindsight seem like they go together, but going forward, you don't really know.
Right.
And so I like to tell people, just follow what you're interested in. There are so many different ways to get where you want to go. And if you speak to literally anyone at NASA, you're going to hear a different story from every single person. They started here and they went here and did this and that.
So true.
So yeah, it's difficult to pinpoint. There's no like step-by-step, here's how you get to where you're going. Here's my intention of where I want to get. Here's what I can do right now, and I'm gonna just follow it until I get to where I'm going.
So a space architecture, specifically a space architecture graduate program, there's only one in the United States, and pretty much I think I was corrected in talking with Olga, saying that it was the only one in the world. So how does a young lady like yourself at University of Michigan with your major discover that this opportunity for a very unique major?
Yeah, sorry, I completely went on the side. And
that's okay. Question. No, it's fine. What you went on the side is what our viewers need to hear anyhow. So I was more than happy to hear that from you.
Okay. Yeah. So I actually, the end of my senior year in college, I kind of didn't know where I wanted to go. I knew I wanted to work at NASA, but I didn't think that with my like current experience, because I did a lot of research in undergrad, but I didn't do any internships. And so I wasn't sure how I'd be able to like get into NASA. So working at NASA or getting an actual position is sometimes really hard because they don't usually have a lot of positions open. But I knew that I wanted to do something in the space industry, and I knew I wanted to work with astronauts. And so I think I was probably just in a lab late at night trying to figure out a project I was working on. And I was like, I really want to work in the space industry and I want to work where the astronauts are. And so I went to Google and said, hey, where are the astronauts? Where do the astronauts train? And they said Johnson Space
Literally.
Yeah, simple stuff like that.
Yeah.
And Johnson Space Center. Okay. And so I kid you not, I said, okay, I'm going to move to Houston. I wouldn't necessarily recommend just on a whim moving across the country.
Up and moving.
Don't have a plan. Yeah. But I searched space. I think I might have just searched like space and architecture together in the same field. And the program that I ended up getting into was the one that came up. So
it popped.
I said, okay.
And what's interesting, I'm sorry, but I wanted to interject. What's interesting about that is space architecture is a relatively new term. It's space architecture has been around since the beginning of space exploration, as I've discussed with the other guests, but being labeled as space architecture has been probably only in the last 10 years or so. So the fact that you were able to Google it and it popped for you, that probably helped a little bit.
Yeah, for sure. It definitely Googled my way to NASA. No, but
so
yeah,
you saw the school pop up on Google?
Yeah, I saw the school, I saw the program, and I thought this is perfect because I think even though I hadn't done architecture in undergrad, I knew I still had the passion for like art and design. And I was really trying to figure out ways to meld those two interests. And so I was really glad that program popped up, and hearing a lot of people who were in my class say the same thing. Like, yeah, I just Googled it and I had never heard of it. I didn't know for sure that that was a thing. It was reassuring that it wasn't the wrong way to find out about the program, but I'm glad that I did that random Google.
Yeah, absolutely. And I think that's pretty cool, actually, that you did it that way. But it also speaks to your focus. So what's interesting to me is you had all of these variants that came into play, and you have now, I mean, well, at the time, you found this school and you got into the program. Tell us what it was like going through this program that you weren't familiar with before you applied for it.
Yeah, so it was actually the only graduate program that I applied to, which is scary to think about in hindsight, but I was determined. It was the only grad program that I applied to because it really fit my interests and what I thought I wanted to do. And then when I got here, I met everyone else in the program. It's pretty small. I think there might have been 15 or 20 people in my cohort. And it was split. So there's a huge diversity of like backgrounds in terms of who, like, maybe half the people were architects by trade. So like they had gone to school for architecture. They had been working as architects. They could design, they could do like all the diagrams for a building, which I could not do. And then there were people who were engineers. So I think we had a couple mechanical engineers, maybe some aerospace. We had one physicist. So there's, if you've ever sat in a room with engineers and architects discussing anything on how to design anything or plan anything, you'll know that they think very differently.
Like, absolutely. One is
very differently.
One is very creative in terms of design, and the other is very concrete. And this goes this way, and this attaches to this, and that. Would that be a good description?
Yeah, and there's a lot of architects will say, "Oh, let's do this," and engineers will go, "We can't physically do that. the laws of nature are not on your side. You can't do that." But I really loved that dynamic because it helped you change your way of thinking, and it really helped. I'd say architects design more with the human in mind first.
Right.
Whereas engineers are more of, okay, this is methodical. We'll get to the human later.
What's practical. And then what you add to that, we're talking space and the effects of space travel and all of those times, or being on a celestial body, as Dr. Benova liked to say. But the effect of that, so that comes into play too. And I think you make a great point that the human factor, which everybody I've talked to about this, that's a major consideration, and mixing that and making that work, has to be very interesting.
Yeah, and that's like central to what Dr. Howard actually does. He's very focused on human-centric design, and how do if we're sending people, we have to think about the people first. And so it definitely helps change your mind frame when you're thinking in that way, as opposed to thinking of like a rover or, hardware. Keeping humans alive in space is a full-time job, and ask
and an
people
important
that work
one at that.
full-time to do that. Yeah.
So as you dove into this graduate program of space architecture, and we're going through it, did it even feel better and better as you did the different aspects of it, heading towards getting that degree?
Yeah, so I think in the beginning, I mean, just as the beginning of anything, you have a vague idea of where you're going, what you want to do, but as you work through it, work towards it, it kind of materializes and comes to a clear idea. And so I'm trying to not go super duper in depth with what I worked on, but ultimately my project was about how do we plan for Mars missions? How do we go from initial outposts to these huge grandiose cities that you see, not going to name any names, but some people, they love to show the images of these huge Martian cities, and we've got like greenery and we've got plants and houses and all this very Earth-like civilization on another planet. But the reality is that we're not even at step 0 right now, right? We haven't gotten humans to Mars yet. And so my project was, how do we get from A to Z? What are all of the steps that we need to build? What kind of infrastructure is that going to require? And so throughout the program, it's definitely iterative. It's like, am I doing this right? Does this make sense? Do I want to go this direction? Or no, maybe this isn't the right way, go the other direction. But I think Dr. Bonova does a really good job of helping folks think through their process and think about how they're going to get to where they're going to get. So I really enjoyed that program, and it fed right into what I'm doing now.
Let's talk about that. Let's talk about how after you graduated with the graduate degree in space architecture, how did that transition you to what you are doing now?
Yeah, so I started working, so I graduated in 2019, and I got a job offer in 2019 to come work for a contractor called Barrios Technology. And
what
they
does
support
Barrios do?
So they support, well, they do a number of different things as a contractor, but the project, or the group that I worked in, supported the ISS programs office. So I did cargo integration, which is like all of the different cargo vehicles that fly to the ISS to resupply pretty much everything that the astronauts need aboard the ISS. So my group worked on working with all the different hardware providers, the people who are trying to get science experiments to the ISS, everything from food to clothing for the astronauts, worked with those folks who provide all of those different aspects, and then the vehicle providers, so Northrop Grumman, Cygnus cargo vehicle, SpaceX, working with them to integrate the cargo into their vehicles to make sure that things fly safely to the ISS. And so that was a really interesting, it was, excuse me, I wouldn't call it an aside because I was at NASA, but it wasn't related to space architecture, but it gave me a really great understanding of how I got, or it gave me a really great understanding of like the structure of NASA and all the different parts within Johnson Space Center specifically.
Gotcha. And so tell us what you do now. Tell us about the job that I have to literally look at to remember how to say it.
Yeah.
Mission analysts and integrated assessments, and then the Mars architecture team. What does all of that mean?
Yeah, so the MAIA group, the first long name that you said, they do, or we do, mission, I wouldn't say architecture, but all the Artemis missions. So we just flew Artemis 1 last year, the end of last year.
Right. Unmanned.
And so, I'm sorry?
It was unmanned to the moon.
Yeah, yes, to the moon. Yeah, so our Artemis initiative going back to the moon, the MAIA group works to define what those missions should be, like what the trajectory should be for the flights. Are we making the right, I guess, it's kind of hard to explain. I've never had to actually explain it out loud.
Just a general explanation. Remember, most of the people watching are not, familiar. So just
yeah.
Okay. Yeah.
Yeah. So MAIA provides assessments about the mission plan for Artemis missions. And so it gets a lot of down in the weeds, like trajectory work. But I'd say overall, we are working to inform the architectures of the Artemis missions. Excuse me. And then on the Mars architecture team, so Artemis is obviously real time, going to the moon, but the Mars architecture team thinks further down the road. And so we've got this Moon to Mars initiative, right? We want to use the moon as a test bed to get us to Mars. And so the Mars architecture team works to define, okay, what should a Mars mission look like? If we're sending 4 crew to Mars, what are they going to do when they get there? How are they going to get there? How do we keep them alive and healthy and well enough to do the things that we need them to do when they get there? And so the Mars architecture team takes a overarching look at what a Mars mission could reasonably be, should reasonably be, and then ask all of those questions so that we're making sure that we're looking for all the answers before we actually go.
Right. And I actually looked it up, some information about it. NASA's pretty thorough about the information they put out about what they're doing. And so I saw that the Moon to Mars, the objectives are really broken into 4 categories, which is what you're talking about: science, and then transportation and habitation, the infrastructure, lunar, both lunar and Mars, and then operations. That sound about right to you?
Yep, that sounds way better than I put it.
Well, no, I wasn't trying to upstage you. I just it's a lot of area to cover, actually, which is, I think, what your point is.
Yeah.
And again, the teams for these type of missions and initiatives are pretty significant in terms of the number of different types of people involved. And the reason that I actually bring that up, Clare, is that I like to point out that there are a ton of opportunities so we're talking about space architecture specifically, and we've mentioned a little bit about engineering and things like that, but there are so many different opportunities and things that can be done within that. And one of the things that was pointed out by Dr. Benova when we talked was that there's going to be the industry, the space exploration, I should say, is growing leaps and bounds, pun intended, and that's going to open up so many doors. So for somebody that's in middle school or high school and they're interested in space exploration, but they don't know, when, where, how, or why, they're just trying to figure it out, like you did. Want to let them know that, yeah, there's whatever your interest is, and you brought this up earlier, and I think that's really important. Whatever your interest is, whatever it is that you like and that you're drawn to, probably it's applicable in some facet or form in space exploration. Would you agree with that?
I would I would wholeheartedly agree with that. I can't say it enough. There's a place for every type of knowledge base at NASA. We've got doctors, at JSC, keeping the astronauts healthy, doing studies on how to keep astronauts healthy. Engineers, of course. And I know people like to think of engineering specifically when they think of NASA, but there are so many different people who are not engineers who are still integral to human spaceflight.
Right. They're a technician or something like that.
No, I mean, even beyond that.
Okay.
Let's say, like, maybe you really like audiovisual AV. I don't know.
Great point. Great example.
We have acoustic testing for, they do acoustic testing for things that go into space to make sure that the vibrations don't interrupt the hardware, right? You might not be an engineer. Maybe you really enjoyed music and you know a lot about acoustic testing. There's a place for every interest, because ultimately we're sending humans to space, and humans are dynamic. Humans are not just engineers. Humans are not just scientists. Humans are not just doctors. Humans are humans. And so if you set the intention and you say, I want to work at NASA, but I don't know how yet, and you're in middle school, follow the things that interest you, because ultimately the things that interest you are going to be the things that you put time into to get really excellent at, to really enjoy, and you'll find a way to get to NASA or to anywhere within the space industry.
In the interim, while you're in middle school or high school, or when you go into college, but let's say middle school and high school, while you're doing what you just suggested, what also should you be doing education wise? What's best in terms of, studying and habits and things like that?
I'm always going to be a proponent for math. You should get good at math, honestly. And I mean, I haven't done middle school or high school math in a while, but that's going to be kind of an invaluable foundation. Even if you don't end up doing something in mathematics, learning math and understanding math changes your brain to think a specific way. Math and science, STEM, of course. There's also, I think, STEAM. Now they add arts into STEM.
Which I like.
STEAM.
I think that's very important because that's the creative side. And I think it gives you some balance and you're not just grinding the books, the hard stuff.
Yeah, and a lot of engineers are like some of the most creative people that I know. So the creative mind is not just for, art specifically. And let's see, middle school and high school, what should you be doing now? I would recommend, and this is also just because that's what I was fortunate enough to do, look at summer programs. I know it kind of sucks to think about giving up your summer in middle school and high school, but
no, but if you're focused, I think that's a really good point. Yeah, and I'm a little biased with it because I just did a show about aviation summer camps.
Yeah,
and it was pretty interesting. And I only featured 3 camps, and there are a ton of aviation summer camps, aerospace type of summer camps. A lot of them are at universities that are aviation centric. Of course, there's Space Camp in Alabama that is really popular, and I've heard nothing but good things about.
Yeah, so I definitely would recommend that. Even if nothing else, what you get an idea of what you do enjoy and what you don't enjoy, and it's worth it, I think. Yeah. I don't ever look back and say, man, I wish I hadn't gone to camp in middle school. I never feel that way. So definitely look into that. And there are a lot of people, at least the program that I did at the University of Michigan, I believe was free. I mean, maybe ask my parents, but I'm pretty sure that it was for the most part free. And it was a 3-week program.
Not sure your parents would have to verify.
Yeah, verify. But it was a 3-week program. We stayed at the University of Michigan. We did an engineering project, and I made a lot of friends that I still actually have today. One of my best friends I met all the way in 7th grade, 8th grade, doing that engineering program. And we went to engineering school at the University of Michigan together. So I can't say enough good things about that.
Yeah, no, this is great. This is a great opportunity to hear from you, hear from someone young like yourself who has recently experienced this and is still growing in her field. And that as we kind of wrap things up, and we've touched on it a little bit, what are your goals beyond what you're doing at this point, or what do you think you want to do? And also, how do you see the future as it relates to these exciting times of us going back to the moon and venturing to Mars eventually?
Yeah, so excuse me, it's kind of an exciting time. People like to compare what's going on currently to like the start of the space race in the 50s, 60s. And I think that there's a lot of opportunity right now because we've got a lot of commercial players also, adding fuel to wanting to go to space. So for me, I mean, I actually just started I can't say just started, but I've only been in this particular position for like 9 or 10 months now.
Brand spanking new.
Yeah, pretty shiny, pretty new. So still, super excited, still learning a lot. It's drinking from the fire hose every day. But I'm really most excited about actually getting people to Mars. Like it would be just amazing if that happens in my lifetime. And I think
would you go?
I wouldn't be the first person to go.
Oh, you
I
want
wouldn't be
you
like
want to
the
send a
first.
few other people out and see how it works out first?
Yeah, I'd send people way braver than me. But I wouldn't go.
That's you being honest. I can appreciate that.
You know, and I think more people say that than you'd realize. And because on the Mars architecture team, part of our like thought process is to think of all the things that could go wrong. And so if you're on my end and you're seeing all the different things that could, you know, okay, we haven't thought about this yet, or haven't thought about this yet. It's going to be a feat of human ingenuity for sure. And so I don't know if I would be first. I'm not like brave enough, but
but you are looking forward to when we are able to send humans to Mars and what that's going to be all entail and that type of thing. Yeah. Awesome. Well, it's been a pleasure to chat with you. We have run out of time. Actually, we've gone over time, but that's okay. Because because you've shared a lot of valuable insight that I think is very important for our viewers and listeners to hear about in terms of your own experiences and your, navigating your way to where you are and still in that process. And it's hats off to you. I mean, it's pretty cool to go from your thoughts from middle and high school to your transition in college, to your transition to the graduate program, to now being at NASA. And I do want to mention, I do have to give a shout out to NASA. NASA is really good with information about what they're doing and information for young people. So I recommend anybody that's interested in NASA in any way, shape, or form to go to their website or just, as you would say, Google your interest and just put NASA as part of that Google search, and it'll pop with all kinds of information about what's going on. And if you get specific with things like Artemis and Mars exploration and lunar, exploration and things like that, you'll find a ton of information. So, and of course you can always.
And sorry, I didn't mean to interrupt, but if there's one more thing I can add.
Sure.
So NASA has a really robust internship program. And I can't believe that I didn't even mention that I was an intern. But intern.nasa.gov, shameless plug. If you're in middle school and high school, take a look at intern.nasa.gov. Take a look at the projects that are available, because that'll give you a real idea of like what someone does on their day-to-day, what projects they're interested in, what projects they're working on. And you can even tailor your interests to that. So definitely use that as a resource.
Thank you for mentioning that. I think that's absolutely incredible. As a matter of fact, NASA's intern program is pretty robust on a lot of different levels. And as you said, as a middle schooler or high schooler, now's the time to take a look and see what they're offering, what the requirements are, when you're qualified for it, and then go for it. And the other thing that you would probably add to this too is don't get discouraged, or if the first thing doesn't go through that you're attempting to do, just stay focused on it and keep persevering.
Yeah, that as well.
Yeah, absolutely. Well, listen, wishing you the best of luck with everything. And it was a pleasure to have you on and talk with you about all of your track, your path. And I'll look forward to seeing your name pop when they're talking about the astronauts that are going to go to Mars and things like that. You'll probably be in that mix somewhere.
Hope so.
Yeah,
for sure.
Absolutely. All right. Well, Claire, it's been a pleasure. Take care of yourself, and wish you the best.
Thank you. It's great talking to you.
You too. Thanks. And that's a wrap for part 2. In the next episode, the final of this 3-part series, I will talk with Dr. Olga Benova. Again, she is the director of the Master of Science in Space Architecture program, Sasakawa International Center for Space Architecture, at the University of Houston's Cullen College of Engineering. Thanks for joining us and hopefully gaining valuable insight from these informative conversations with very talented and brilliant, I might add, NASA professionals. With every show, I do my best to provide as much exposure as possible to any and everyone who has any interest in literally any aspect of the aviation and aerospace industries. Of course, if you like what you're hearing and seeing, I would ask that you please subscribe. Until next time, take care, stay safe, blue skies, and have a good one. Hi, I hope that you've been enjoying these 3 shows on what space architects do and their significance with the designing of space habitats for human space travel. I'm Vince Mickens, and this is All Things Aviation and Aerospace. As we wrap up the series with the 3rd interview, it's important to note that it all starts with education, and that's where Dr. Olga Banova fits in. As the director of the Master of Science in Space Architecture program with the Sasakawa International Center for Space Architecture at the University of Houston's Cullen College of Engineering, Dr. Banova talked with me about their unique program and incredible opportunities it provides for the next generation of space architects. I hope you enjoy our conversation as much as I did. Dr. Banova, welcome to the show.
Thank you very much. I'm happy to be here and talking to you, Vince.
Yeah, thanks. It's great to have you here. I'm very excited about our conversation coming up. Just talked with Dr. Howard and got some perspective on it. But what's great about your side of it is the education side, particularly at a university that has a program that's one of the few in the world, actually, that's specific to space architecture. As we were talking about, I was talking about that with Dr. Howard and mentioning to you before we switched over that space architecture is kind of a new term, even though it's been around since space exploration began. But now it's the term for describing the whole thing about habitats in space and things like that. So I think it's pretty interesting, and I really want to dive into it a bit, so that we can give our audience an idea of what space architecture, not only what it is, but what the opportunities are with it in terms of how you steer your education that direction and things like that. Why don't we start out a little bit and you tell us about your background, your education, and your path to where you are now.
Okay. Well, one correction, actually. So the Master of Science in Space Architecture is still the only one in the world. It's the only degree. So there are different programs when they teach, and students, usually architecture students, are learning about space. And usually it's still within their architectural curriculum. But a degree, Master of Science in Space Architecture, recognized by Texas Higher Education Board, is the only one in the world. So we're still very special.
Yeah, it is. So talk about that a bit. Tell us about how space architecture has evolved.
First of all, I learned about the center when I just arrived to Houston and started my master's program in architecture here at the College of Architecture at the University of Houston. It was some ancient times when the websites weren't very common, and the internet was, of course, around, but it wasn't at the same level as now.
Sure.
So I only learned that center exists when I came to the school, actually. And I was always interested in space and all. And
okay, so you were interested in space, but you didn't know there was such a thing as space architecture?
No, I didn't. And at that point, it's still quite few people were working on projects related to space and looking at space habitats, designs from architectural point of view perspective. But it wasn't that much recognized as it is right now. And
as something specific.
yeah,
So let me backpedal a little bit with you. And you studied architecture before you came to Houston, correct?
yes. Mm-hmm.
Okay. And you've always had a thing about space, so to speak. So was Houston what put the two together for you?
Absolutely, yeah. So it's again, probably it's how it happens. Like if you even consciously or unconsciously set up and look in it, so that's the first thing that you notice. And that was the first thing that I noticed about the College of Architecture, that this center is here. The program wasn't established yet, but the Center for Space Architecture was already here.
So you were excited about that when you saw that?
Yeah, so that was something, because I was always interested as architect in working on very complex projects. And in my mind, it was all urban big scale projects, putting things together and connecting dots together on this global scale and on the very complex scale was something that's very exciting and something that architects can do. And again, what most challenging could be, what more challenging it could be than designing for space, right?
Absolutely, because of the environment, et cetera. So, and what a great challenge. So tell us a little bit about the center and then how that transitioned into a program to where it is now a graduate program there.
Yeah, so two major things happened in 2002. One was that International Astronautical Congress was here in Houston, and this is the largest gathering, the largest event in space industry. So when all agencies and industries and academia usually present and talk to each other, and it's a week-long event, and that travels from city to city, country to country every year. So it was 2002 when Houston hosted it, and that thing happened. And then before that, or actually of the same year, we had a group of engineers from Johnson Space Center who came to the center, Sasakawa International Center for Space Architecture, and they said that they want to learn about space architecture, and they want to learn about architectural approach, architectural methods, and they want to work on the Mars project. At that time, it was first wave of Mars exploration was announced and that we're going to Mars, and then all the settlements on Mars projects and ideas were brewing and flourishing, or started flourishing then. So those engineers came and said that they want to learn about it, they want to be part of it, but in order to work on their project and learn and participate in classes, they have to get a degree. And so NASA would support their studies.
Gotcha.
And that's how we kind of very quickly put together a program, a curriculum for them. And while they already started taking classes and working on this project, we were working also on making this degree approved by the university first, and then by the Texas Higher Education Board. So that happened in 2003. So when they graduated, they were first Master of Science in Space Architecture graduates.
Got you. And all of them, they had different types of engineering degrees, or a specific engineering degree?
Different, yes.
Different ones.
Mm-hmm.
And now they have a graduate degree in space architecture. And that program has been going, you said, since about 20 years now.
Yeah, exactly. We're celebrating 20 years this year.
Yeah. That's pretty interesting. So, and you've been director of the program for how long now?
Since the center was moved administratively from architecture to engineering, and that happened, finally, it was finalized in 2014 and or rather beginning of 15. And at that time, Dr. Bonnie Dunbar, was
Yes.
director briefly. She was at that time at the University of Houston, and thanks to her, the program was moved to transition into engineering. But then she left to TAMU, and I became a director in 2016.
Gotcha. So this is pretty interesting, and I love the track that you have, so you can even explain it better of the discovery you made and the transition you made in terms of the graduate program for space architecture. All of that said, what do you share or recommend to students that may be engineering students, et cetera, that now are maybe an architectural student, but realizes that they could actually do something called space architecture?
First of all, you have to have that passion for this, for design. And that usually when somebody asks me about the program and potential applicants, that's what I tell them. So should be interested in human space flight. You should be pro human space exploration, and excited about designing for humans. We do it for people, right? So as architects, that's people, our clients.
Yeah.
That is, we need to think about all aspects of human life, but at the same time, we should really respect and satisfy all the requirements, engineering requirements for systems to supporting also human life, supporting whatever activities they have to perform during their mission, but also provide support for the engineering parts, for their spacecraft, right? For their
Right.
space habitat, thinking about infrastructure if it's on the surface. So how it's all part of the bigger infrastructure, how it's a part of future growth, what will happen next. As we are, well, we are not completely done with 30 missions, but we want those 30 missions become a part of some sustainable presence on the surface of Moon or Mars or elsewhere.
Right, exactly.
So that's something. That's what I usually tell them. And our program is multidisciplinary, so we have engineers and architects and industrial designers, product designers, because also students are coming from all over the world, and with different types of degrees. But it should be, you should be interested in design. You should be able to understand, or have this desire to understand and learn about these complex systems and how you put it together and how it will work for supporting human operations.
Right. Yeah, the complexity of it was something that I talked with Dr. Howard about, and just in general with what you're saying too. It actually takes a pretty large team to put something together that's a habitat for, whether it's an orbital habitat or something on a planet. And one of the things that we talked about was you have to be, as you're talking about, aware of what will protect the humans that are in these habitats, both, whether it's on the planet or in orbit, because one of the big factors is we have an atmosphere that protects us here on Earth, but you don't have that necessarily in a, and maybe you can speak to that.
Oh yeah, absolutely. Of course, safety is the first thing, and protection from all the hazards in space, so on the surface of other celestial bodies, let's put it this way, in general.
Right.
So that's the must, all right. But also considering what is happening inside the habitat or inside those pressurized structures where people are, that has to be also safe. and ergonomic, of course, it's part of it, it's part of human factors. But it's also should be convenient and responding to their needs during the long period of time, if we're talking about long mission. So things are changing, the environment may be changing, their tasks may change. So humans should be able to interact with their environment and also improve it if it's needed, or adjust it to their needs and their desires and their liking some point too. So that is part of it as well. So we always considering protection, of course, as a major thing. Has to be pressurized. We have to provide some radiation protection, temperature control, and all of that. That is just survival. But then we're thinking about living, and then we're thinking about productivity of the crew, and also their physical and psychological health, their cultural background, social interactions. There is such a term as crew or team resilience, and that is very important to support that as much as possible, because then they will be able to respond to different situations and dangerous situations or whatever. So when they will need to make a decision very fast. And if they go farther and farther from Earth, they will get less and less immediate support from the mission control, let's say.
Right.
The time delay is a real thing.
Especially going to like Mars as an example.
Yes, yes, absolutely.
Where it could take up to 6 months.
Yeah, even on the moon, if we're talking, for example, medical operations and medical situations. So if there is some serious surgeries happening, or it has to happen, and the crew doctor will have to have support or advice from Earth, delay even in a few seconds can be too much.
Right. No, that makes a heck of a lot of sense. So it also says that you can be a space doctor. You can be a doctor and go with the crew out there to the moon or to Mars. A couple of things that come to mind. One, as I was going to ask you, is there any specific collaboration that your College of Engineering is doing right now with NASA?
Well, there's a faculty, they work on different projects related to NASA, and one is with robotics. Can't tell you exact names, but it's always something that goes on the UH campus. NSM, so natural science and mathematics professors, work with Johnson Space Center, quite a few of them very closely. Even in geology, there is professor in geology department who worked on Mars geological.
Right, and I know there's people out of JPL also that are working with that are geologists that are working on things like that.
Yeah, and radiation issues too. So Professor Dr. Pinsky is also working on this long-term project with NASA, with Johnson Space Center. It's going on constantly. So
yeah, well, I on the radiation side of things, I mean, a long trip to Mars in open space, so to speak. I understand that radiation is a major concern as to how to keep that in check or mitigate that to protect the astronauts. I wanted to ask you about your curriculum there for the graduate program. Just a brief overview, if you could, of what the curriculum consists of for your students.
Well, we have required, of course, it's we called it Steel Studio. It's inherited from architecture, and this is project-based studio classes where students working first semester they work. New students when they join, so they work on a team project, and it's 1 semester project usually. And then they continue on with deciding on their master thesis project and started doing their research. It's a short program, So if you do it full time, and this is speed that is suggested for these full-time students, it's just 3 semesters, 30 hours. So second semester is research oriented, and then the concept development semester, and then the final semester is when you finalize your design, your master project, and basically write thesis and present your thesis and like that. So classes, we have about, of course, habitat systems and integration, and another one is mission planning and design influencing factors related to mission planning. But it's really hard actually to separate one from another, even though our classes,
they kind of overlap.
Yeah, because it's, again, you cannot design a good habitat that is disconnected from understanding of mission needs, crew size, obviously, the duration of the mission, then also why you're going somewhere. So again, purpose of the mission goals and objectives at different stages of the mission as well. So the question why is always the big question, and it's always emphasized to the student that you have to ask this question yourself all the time. So why, and test and analyze your own theories or concepts from that perspective. So I'm trying to teach everyone with this, of course, critical thinking, and really follow that logic of, cause and effect from design point of view. So if you suggest some decisions, to see how that will affect the whole system or maybe the whole mission. So where you go with it, and that's the major thing. So also now that talking about like what Dr. Howard mentioned, that it's a big team of professionals, architects, engineers, designers, scientists working on the project together, designing a habitat, let's say. And the same thing in our studio, in our classes, the group of students with different backgrounds working together, learning from each other, and learning each other's language, so they can understand and listen to each other, and not dismissing somebody's ideas just because you either don't understand or don't think it's not that important. Everything is important. It's almost equally important. When you design a space mission and you want your crew safe and sound, and return back not only physically healthy but also mentally healthy.
Absolutely.
Totally liking each other.
So the team projects that your students work on, do they tend to be related to what's current in terms of the moon and Mars and things like that?
Absolutely, yeah.
Okay, yeah. That'd be pretty exciting to do that. I know if I were doing a graduate program like that, I would want to do something that was relevant to what was happening today, with the moon being the first stage of that, and the next one being Mars. Speaking of that, we were talking about, so the moon is relatively close proximity as compared to the closest planet at a certain orbit, like Mars. Much of a difference between what you work on or focus on, I should say, for those two, what did you call them, celestial bodies?
They're all celestial bodies, right?
Yep, exactly.
Also, of course, moon can be and is considered to be a big test bed for Mars missions, but conditions are very different from many perspectives, and that's part of again the design challenge usually. So to see what is different and what are the influencing factors for the design, and what comes from the environment. There are also design influencing factors that come from the crew and mission objectives and mission needs.
So Go ahead.
No, well, so obvious differences between Mars and the Moon is, well, atmosphere. There is still some atmosphere on Mars, right? It's thin, but there is atmosphere. The pressure, there is atmospheric pressure. It's very, very low, but still there is atmospheric pressure. Landing something on Mars is more challenging than landing something on Moon, and the same thing launching from it too. Not even talking about the distances, how you get there, but even this landing launching operations are different. Then again, regolith on the Moon is different from regolith or ground on Mars, right? The dust on Mars.
Right.
So different quality and different ways of how it can affect surface operations.
Yeah, I was just thinking about the fact that also, so a lot of the information, like the Mars rover that's currently there, that's been now there for a couple of years and continues to send back information. Plus, it has geological information that will be our geological samples that will be brought back in a few years. Apparently, it takes quite a bit of time to get that stuff back here from Mars. But my point is about the information that the data and information, does that play a large role for what you guys do as space architects in your designs and systems?
Absolutely, yeah. More data you can get is better. That's the major issue with designs and working on designs for Moon or Mars or else. That the lack of solid ground information. So we have to make a lot of assumptions. And
Okay.
that is, again, understanding the limitations of those assumptions, or those assumptions posed to the design solutions.
Yeah, calculated assumptions, right?
Yes, yeah. So we don't know. Yeah, so more we will be exploring, more we'll know. And of course, once first missions will be there, and hopefully the first habitats will be there, then when the real learning will be happening, when actually those operations will be in situ.
So as we kind of wrap things up, one of the things, as I mentioned before the show and also during the show, is that our audience are exploring what opportunities might be out there for them in the industry, on the aviation side and on space exploration side. And being a space architect or becoming involved in that is really a unique and very specialized and great thing, I think. From your perspective, your experience and all that you have done, and having students that you stay in contact with that have graduated, students that you have currently, et cetera. For somebody a parent or a student in middle and high school that are, kind of thinking about what they may want to do, they're interested in space, they're fascinated by it. What kind of feedback or advice do you have for them as they start to try to move forward?
Oh, well, again, there's follow your passion is the first thing, and then
follow your passion. That's your number one, huh?
Yeah, that's number. You got to love what you're doing. Life is too short to waste it on something, and we spend way too much time working. And if you don't like what you're doing, it's torture. Why torturing yourself?
True. Very true.
And feel sorry for yourself then, it's not productive at all.
Yeah.
So that's a major thing. But actually, right now it's getting more and more exciting to be in the industry and work with the project.
Absolutely.
And commercial spaceflight, I really wish all the success to everyone who is proposing their orbital facilities, and Axiom is the first one, but now the other ones, Blue Origin, NanoRax, and Sierra Space, right? And so it's all great. And now graduates are working there in the field, so they're working in these companies. and becoming part of that future. Hopefully, that only means that more workforce will be needed for that. Well, again.
Oh, absolutely. It's wide open right now. And as you said,
Yeah.
it's a very exciting industry. And with all the goals related to the moon and Mars, there's just going to be a lot to offer. And as you said, the workforce is expanding exponentially.
Yeah. And of course, the In-situ resource utilization, so ISRU, that will be, again, developing, and we got to do that. So on the surface of the moon, especially on maybe potentially with asteroids. So there are many aspects. It's like architecture in general is a field of architecture, like a discipline of architecture. It's very multidisciplinary itself, if you wish, or because there are so many different ways how you can find your niche in this, being an architect. You can be more, like I was interested in this big system structure, so you can be more interested in, I don't know, historical heritage buildings, or you can be more interested in, I don't know, even landscape architecture, or different types of architectures, right?
Right.
And with space industry, and what's this young generation that who are at in the high school or middle school right now, so for them it's the same thing. So just think about what you're more into it. So if you want to start with your engineering background and pursuing mechanical engineering degree, very generic, and then go to get more information, get more training as a space architect, understand the architecture with that, you can do that, or vice versa. So you can do architecture if you're interested and want to explore that part of space architecture, you can do that, and then become a space architect as well.
Sure.
So that is like the more you can find, the more information, and you can take more classes. So diversify your knowledge is good, because then it will be easier to really find what is you.
Sure. If you were to guess, and I do have to wrap us up here, but if you were to guess in the future, what would be next after the moon and Mars? What do you think that might be?
A lot depends on propulsion systems, and if new propulsion systems, not only chemical propulsion, would become possible, so then we can go beyond Mars. I'm talking about human missions.
Yeah.
And that's what I really hope for. So then we can go to Titan or Enceladus or Europa. That would be something.
Yeah, he sounds just like Dr. Howard. He was saying that too, and he said actually there is a new propulsion system. I forgot the name of it already. It's kind of like a hydro propulsion or something like that. Very sophisticated, very complicated propulsion system that's being worked on, and if that's becomes a reality, then that would be pretty exciting. And there are some young people that I actually one in particular that's at Georgia Tech, getting her PhD in propulsion systems, and she's probably one of the ones that'll be working on that future type of system. But that makes a whole lot of sense. I guess we need the Star Trek thing.
Yeah, well, the warp, yeah, that would be nice. But before that, probably we just can start with nuclear and thermal propulsion systems. That will be already good, and plasma.
Yeah. Well, as with Dr. Howard, I probably could have talked to you for the entire show, just you, to talk about all of the things that are going on in space architecture and the opportunities. But we have to wrap it up, and I do appreciate you joining the show to tell us a little bit about and give us some perspective with the program that you have there at the University of Houston Cullen College of Engineering. So thank you very much for joining the show, and appreciate it.
Thank you very much for inviting. Yes, and I enjoyed talking to you and talking about the program at any time.
Well, That does it for my 3-part series of interviews regarding space architecture and being a space architect. As you could see and hear, all 3 of my guests are very passionate and excited about what they do, and are looking forward to seeing more aspiring young aerospace professionals explore this very unique and specialized profession. They're also very open to sharing advice with any of you, so feel free to reach out to me and I will definitely put you in touch. Thank you for joining us. And as you know, with every show, I do my best to provide as much information and exposure to new possibilities for any and everyone who has an interest in any aspect of aviation and aerospace. I encourage everyone interested to consider every possibility and the many options available. You've been watching and listening to All Things Aviation and Aerospace, a presentation of Private Air Media. If you like what you're seeing and hearing, I'd appreciate you subscribing. Until next time, please take care, stay safe, blue skies, and have a good one.